Hello everybody, welcome to today's episode where we're going to be talking about managing Docker containers with the help of Kubernetes. So this is a beginner fresh lab for Docker and Kubernetes, something where you're brand new to this stuff and you can just hop in and follow along with me to get your first lab done with Kubernetes and Docker. So before we get started, let's discuss the fancy word. What is Kubernetes? What does that mean? Well, Kubernetes, or K8 for short, is an open source toolkit for building a fault-tolerant, scalable platform to automate and centrally manage containerized applications. The platform itself can be deployed within almost any infrastructure in the local network, server cluster, data center, any kind of cloud. Public, that could be, Google Cloud, Microsoft Azure, AWS, or anything else. So private, which could be your own cloud, or hybrid, like a mix between on-premises and a public cloud, or even a combination of any of those methods. So it is noteworthy that Kubernetes supports the automatic placement and replication of containers over a large number of hosts. And that brings us to the second question. What is Docker? Let's actually bring up a picture of Docker. So as you can see, Docker portrays a new outlook on how to code. It's an image of a whale with shipping containers on it, and each shipping container could be filled with code. And now imagine this. Imagine you're at a harbor, and when the boat docks at a node, and the node could be the harbor, right? So when the boat docks at the harbor, it can drop off all these containers, and all those containers are essentially code coming in, so inbound code coming into the node. And the node can also load it up with code that it wants to be shipped out, and that can be called outbound code. And that will be shipped off to another harbor, which is essentially another node. And so that's a pretty cool way to look at it. And to add on to that, let's say the boat is also automated. So let's imagine the boat drives itself, and there isn't actually a captain on it. So all you have to do is orchestrate what goes in and out of those containers and where the boat's going and accepting where it's coming from. This is where Kubernetes ties into Docker. We can go a level even deeper and say, instead of orchestrating what goes in and out of those containers, we can get Kubernetes to automate that as well. So AKS, which is Azure Kubernetes Services, can decide what goes in and out of those containers. Docker works with containers. Kubernetes works with the container groups. It goes a lot deeper than that, but that's the nutshell of how it works. So Docker is an open platform for developing, shipping, and running application. Docker enables you to separate your applications from your infrastructure so you can deliver software quickly without the concern of what type of operating system the host and end user may use. With Docker, you can manage your infrastructure in the same ways you can manage your applications. And so let's go on and get started with this exercise. Enough of me talking. Let's pick a hypervisor. For this lab, I'm going to be using Oracle VBox. And VBox, if you don't already have it set up, all you got to do is go to this URL. I'll put the link in the description below, no problems. And from there, you just click on Windows Hosts, and that will automatically download it for you. From there, we have to download two different packages, and these links are also going to be in the description below. So the first package is this one, and the second package is this one. So the first one is a Kubernetes controller, and there's an install guide for Linux, or we can go down Mac. Nope, we're going to be using Windows. So for Windows, we can just go ahead and click on download the latest version, and that's an embedded link. And if you click on this exe, it's not going to do anything. There's a certain way to install it. So let's go over to Minikube and do the same thing. There's a way to use the Windows Package Manager, so you can type this into the command prompt, but you need this installed, the Windows Package Manager. Or we can use Chocolatey, but again, you need to have Chocolatey installed. So, assuming we don't have either of those, it's okay because we can click on this Windows installer where it installs these for us. And neither of these are actually executables that are going to do anything. So we're going to have to take both of these files and copy them, go under this PC, local disk C, and we're going to name a folder called Cube, just like this one. And we're going to paste those into here. And Minikube, you can just rename it so that it just says Minikube. And in order to test if these are properly installed, we just go and open up a command prompt and type in kubectl. And if we don't get any error messages, then we know it's installed correctly. So that's all you get. It's super easy. You just download it and it's already running on your system. So now here it goes over, it's showing that, this is the Kubernetes cluster manager. That's what this is. And here's some basic commands to create, run. There's some intermediate commands to, get or edit or delete. There's deploy commands. There's cluster management commands, troubleshooting and debugging if anything's not working correctly. There's advanced commands, there's settings, other commands. So it's a whole manual when you type in that command. So, and now in order to do the Minikube start, it's kind of the same command. So we can go ahead and type in Minikube start. And for me personally, it's not going to work because I have it set up with Hyper-V. But for you, if you've never done this before, it's just going to work probably. But for me, it's not going to work. So let's yeah, see, it's using Hyper-V driver based on the existing profile. So what we're going to do here is we're going to set the default driver. So the command for that is minikube start VM driver equals VirtualBox. And it doesn't like it because it wants me to be running PowerShell as administrator. So let's go ahead and open up PowerShell and right click, run as administrator, hit yes. And we're going to do, so we can try just setting it as our default driver by doing minikube config set driver VirtualBox. So now we can try to, I already have some Minikube containers, so I'll go ahead and do minikube delete. So now the Minikube cluster is deleted, and now we can start a new one. And let's see if it works. So right now what's happening is Minikube is trying to create a virtual machine in my VirtualBox program. So as you can see, this is the new one that is just created, and it's showing that it's creating it still. So we got done. Kube cluster manager is now configured to be using our Minikube. So it's looking good. That means we can go on to our next step. We can go ahead and type in Minikube Dashboard. And this is going to open up this dashboard. We created this. This is so cool. So as you can see from the dashboard, we have a lot of side menu things and a lot of information on a lot of different stuff. And it could be overwhelming to look at, but with time, we will slowly make sense of this chaos that we're looking at. And in this walkthrough, we will mostly be focusing on workloads, deployments, and services. And as we talked about earlier, Kubernetes is made to easily deploy Docker images and to orchestrate all these different containers and just to make our lives easier when working with containers and images and Docker. And so we will see in the upcoming steps how simplified it can be to do something so seemingly complicated. And the first thing we're going to do is go under the workloads and deployments. And as you can see, there's nothing to display here. So we can go ahead and add a new deployment. And now we can create from an input or from a file or from form. For the app name, we can put anything we want in here. I'll put in Angular app as that's what I'm going to be deploying here. And for the container image, we can use a Docker URL. And now this is from a Docker hub. And what that means is this is kind of like GitHub, but for Docker. And this man, Husam, created his own Docker images. And essentially, I get to test with his Docker images, or I get to work with him. And he is the author of this. I don't actually know who he is. And if you're watching this right now, thank you so much for creating your awesome images so that I can be doing these cool labs. So anyways, the URL path I'm using is this, and I'll be posting that in the description below so that you can follow along with me. Next, we choose any number of pods that we want created across our cluster. For this exercise, I'm going to be picking 3. Next, we decide if the service is none, internal, or external. Internal means the service won't be exposed to external users. It will only be available to users within the pod layer. This prevents anyone from the outside to access the service. External means the service will be available to external users. So let's make this simple and go with the external service option to make sure that we can access it. And from there, we can select a port and a target port and a protocol. So let's fill in. I'm going to be using 31000 for the port and port 80 for the target port. That's HTTP, which is a TCP protocol. I'm going to go ahead and deploy it. And as we can see, there are 3 orange, and then they turn red, and now they're green. So as you saw down here, maybe, before it was 0 out of 3. And as soon as they turn green, now we got 3 out of 3. What that means is all 3 of our pods are up and running. And it's showing how long ago it was created, showing the labels. We can always add more tags to it. We can change the namespace. For using our own DFS namespace server, then we can add it to that. And here we can see all 3 of our pods and the pod names. And from there, we can see our replica sets, we can see our discovery and load balancing, we can see our configuration and storage. So you may notice that this one right here is the only one that's not showing a green arrow. And don't worry, it isn't broken. And if you can see by the name, it is a load balancer. The reason why it hasn't loaded yet is because we most likely don't have a load balancer in my local machine. We usually use them through Azure Cloud or Amazon Web Services or Google Cloud. So in order to fix this, we need to change the type from load balancer to node port. And we can do this by going into the interface and going to edit. Whoa, we just got a block of code. So don't panic. I will try to explain everything that's going on here. So you can click on the YAML tab or the JSON tab. They are both showing the same information, but JSON uses a lot more brackets and it might be harder to look at. Let's take a moment to look past all the symbols and numbers and confusing little things. The first thing, it tells us that it is a service. So it shows kind, service. It shows us the API version, which is v1. Then it shows us the metadata. It shows the name, Angular app. Well, that's the name we gave it. Then it shows the namespace that it's under. See, all of the little bits of information that we were seeing on the dashboard, this is where it's all written out in the YAML or JSON format. So this is the resource. You know, if we scroll down, we can see that port that we set it to. Here's the port 80 because we set it to HTTP, and that's where, you know, it put the input into. So here is the part that I want to focus on. We are running this on our host machine, not on an Azure cloud, so we don't have a load balancer right now. And we don't really need to set one up either. So we're going to change this load balancer and delete it and type in node port. And as you can see from here, we already have a node port number, and that's 31013. You can change it or you can set it to whatever you want. I'm just going to go with the default one, as that's just the one that it gave me. And if you're editing this using JSON, the same thing. You just come down here, you put the type to node port instead of load balancer, and then the load port number, you can edit it if you want to. But again, when you change it here, it changes here. So you don't need to edit in both places. If you are editing in JSON, remember to include the quotes and the comma. Now we're going to hit update, and we're going to go and click on the Kubernetes logo in the top left-hand corner to go back to our overview dashboard. So now if we scroll down, now we don't have the little questionable logo anymore. We have a green check mark now. And if you see this with me, that means we're winning the fight. And we can now click on it to see some more details. Resource information, it says node port, and here's our cluster IP, and here's our session affinity. So there you have it. Thank you for watching. Our Angular app has been deployed, and from here, I just want to have a few concluding endpoints to talk about. So Kubernetes also makes it very easy to update and scale applications. So to update apps, we can change the tags that the image use, and to scale, we can increase the number of replicas used by our Docker image or the number of pods used by our service. So how would we increase pods? Well, if we go back to our overview and go under deployments, click on our Angular app, and up here with this, and up here we can click on this little logo here where we can change the amount of desired replicas. And desired replicas is just the other word for pods. So you can change the number here, or you can go under the edit and just change, and we can go down to line 99, I believe it was, where it shows replicas 3, and you can change that number there as well. And that's all I have for now. I hope you found some value in this video, and I hope you were able to follow along. If you had any issues, please feel free to leave a comment below, and I'll do my very best to get back to you and help you out. Thanks for watching. Bye.